Hello, my name is Scott Swartzwalter. As the program manager at UEC Electronics responsible for all vehicle power systems programs, I'd like to take a few minutes to talk to you about our Distributed Power Control and Monitoring System, or Dpcms. Dpcms was designed and developed by UEC Electronics to address the United States Marine Corps' legacy electrical system on their Light Armored Vehicle, or LAV. As the Marine Corps' maneuver warfare mission evolved over time, new C4ISR systems were developed and fielded onto the vehicles. This resulted in numerous issues, such as unstable power, damage to equipment and hardware, wiring schematics that were overly complex, resulting in massive cable runs throughout the vehicles, inadequate power for mission-critical systems, and excessive time to troubleshoot issues and make repairs to the vehicles. As you will see throughout this series of videos, while Dpcms was developed for the light armored vehicle, it can be deployed across the entire range of tactical wheeled vehicles and ground combat vehicles throughout the Department of Defense. Dpcms is a dual redundant, digitally controlled power backbone for military vehicles. Before going into how the system works, I'd like to talk to you about the key components of the system. First, we have the Power Distribution Module, or PDM. It consists of a 300 amp input and 4 75 amp output channels. Next is the Power Control Module, or PCM. It has 70 amp input and 12 15 amp output channels. The next component is the Video Display Unit, or VDU. The VDU may also contain the System Control Module. If the System Control function is not integrated within the VDU, it is a separate module not shown here. Finally, depending on the application, you may have a Driver Interface Panel, or DIP. This is the DIP that we developed for replacing the legacy DIP in the light armored vehicle, which is this big box down here. Just to give you an idea of the space and weight savings from our system, I'm going to turn this massive box around, and as you can see, I'm somewhat straining. It's extremely heavy and filled with legacy type electrical equipment. Now I'm going to walk you through our brass board that we developed as we were fielding the light armored vehicle system. This brass board we use to do our software debugging on. This particular variant of the system has 4 PDMs, or power distribution modules, and 7 PCMs, or power control modules. For any particular military vehicle or specific variant within a vehicle family, the number of PDMs and PCMs may differ according to your power needs. So on this system here, you can see that we have 3 video display units. This is a representation of the driver interface panel, and the lights and knobs that you see up here are all replicating actual functions that would be performed on the actual vehicle itself. The next feature that I'd like to demonstrate for you is the dual redundant capability of Dpcms. When we talk about dual redundant, we're talking about the paths available to accomplish a certain task on the vehicle. We have dual redundant capability for all critical functions. And when we say critical functions, we mean anything that comes in the areas of shoot, move, or communicate. To demonstrate that, I'm going to move to the driver interface panel and I'm going to engage the engine start switch. You'll notice that this light has illuminated up here on the board. What that means is I went to my vehicle, I started it up, and that function has actually occurred on the vehicle. I'm going to do the same thing now, but I'm going to introduce a fault into the system and show you how the system adapts and overcomes. So go to start the engine, flip up on the toggle switch, primary light comes on. Now by pressing this black button, I'll be introducing a fault into the system, and you'll see that the primary light goes out. You'll also notice that the light next to the primary light just came on. So what the system has done is the primary path had a fault in it. So it rerouted itself so that it could still accomplish the task that the operator was intending to accomplish. The next feature I'd like to demonstrate for you are the video display units, or VDUs. For the systems that we outfitted on the LAVs delivered to the Marine Corps, we had 3 VDUs on those vehicles: the driver's VDU, the vehicle commander VDU, and the troop commander VDU. On the driver's screen, you'll see this is the typical view that the driver would see. A unique feature of our system is that from any particular VDU, you can get to the screen view of the other 2 very simply. And I'll demonstrate that for you on the driver's VDU. So this, again, is typically what the driver would see. I'm going to go up to the main menu, and I'm going to select the commander's view, and you can see that that changed. And now if we look back over at the vehicle commander screen, you can see that the 2 views are the same. What this allows for is better situational awareness inside the vehicle while keeping down on intra-vehicle communication. Thank you for taking the time to watch our videos on the revolutionary distributed power control and monitoring system. In summary, Dpcms offers clean, stable, reliable power for all C4 ISR equipment integrated onto tactical, wheeled, and ground combat vehicles. Additionally, critical vehicle systems such as shoot, move, and communicate functions have the added benefit of dual redundant power. Maintenance and repair times are drastically reduced. With diagnostics built into the system, there's no need for special tools or equipment to work on the system. It's completely scalable for your future vehicle needs and to apply to other vehicle applications. Should a failure occur, all of the components are hot swappable via plug and play, and they have auto self-discovery so that when they wake up in the system, they know exactly the function that they're supposed to be performing. So in closing, Dpcms offers a single product that's completely scalable to fit all of your vehicle power needs. It's been proven through rigorous U.S. government testing, and we thank you for your time for watching these videos. For UEC Electronics, I'm Scott Swartzwelder.